looking at how to find all the possible rational zeros of a function, okay, of a polynomial function. All right. I want you to highlight the number that's in front of the x cubed, the leading coefficient, and then highlight the constant at the back. Label the constant at the back p, and the coefficient, the leading coefficient in front of this x cubed, label that q. What we're going to do in your journal is you're going to write list all factors of p. And then you're going to write list all factors of q. So we're going to put all the factors of p over all the factors of q. Well, q is pretty easy. What's all the factors of 1? 1. What are all the factors of the number 12? 12 and a 1. 6 and 2. 4 and 3. There we go. So could you guys please list right here all the factors of p? We're going to list them as a 1, a 2, a 3, 4, 6, and a 12. Now, when it says list all the possible rational zeros, all the possible ones are all of these numbers divided by the number 1. So my possible answers, this is what I want you to understand, are technically a plus or a minus 1, a plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. These are all the possible zeros of the function. They're not all the zeros, they're all the possible zeros. Now, what I'm going to let you guys do, all right, for your assignment, I'll let you put plus or minus, and just put a set of 1, 2, 3, 4, 6, and 12. So I'll let you guys put that so you don't have to do plus or minus in front of all of them. But please don't make sure you put a plus or minus in the set. Okay? Right. Lets me know that you're dealing with all of these. Now, which one of these now? Obviously, we have a graph calculator. We can type it in. You can find exactly where the zeros are located. Okay? What we're going to do is we're going to use some synthetic division. Okay? And if you didn't have a calculator, here's the cool thing. If you don't have a graphic calculator, these are the only one numbers that you want to test. You're not going to test the number 7 or the number 8, only what? All of these. So right now, let's do some synthetic division, and we will test some of these numbers. Once we find them, then we found a 0. So right now, we have x cubed, x squared, x to the first, x to the 0. We've got a 1, negative 1, negative 8, and a positive 12. Now, of these numbers right here, which number would you like to test? You want to test 6? Okay? So right now, don't, on your papers, don't write 6. I'm going to write 6. But don't write 6 here. Bring down the 1, we get a what? 6, add them together, 5, here we get a 30. Automatically, once you get to this point, what do you realize? This is not going to get you to a what? This is not going to get you to a negative 12. So you can stop doing that number and say, you know what, that's not gonna work. All right? Let's try a negative 3. Bring this down, what do you get?
3, negative 3.
Add them together.
Negative 4.
Multiply.
Positive 4.
Add.
Negative 4. Not positive 4, my bad. Negative 4.
So what do we find? We found that negative 3 is a what? It is a solution. It is a 0. So one of our solutions, I'm going to write, one of our solutions is at a 3. Now what does this leave us with? That leaves us with 1x squared. That's an x to the first. That's an x to the 0. So right, x squared minus 4x plus 4. Once you get to this, you ask yourself, can I factor this or not? This is an example, everybody, of something called a sum of squares. By the way, what I want you guys to understand, this is different than what's called the difference of squares. So in your journal right now, I want you guys to write down the difference between a sum of squares and a difference of squares. My board is not reacting. Okay? So the sum of squares versus a difference of squares. The sum of squares is this. If I have a plus b times a plus b, that's what's called the sum of squares. The difference of squares is a plus b times a minus b. This multiplies to a squared minus b squared. This becomes a squared plus 2ab plus b squared. So here's some basic ones you need to know. X plus 1 times x plus 1. This one you need to know. X minus 1 and x plus 1. So I'm going to list a few right here. I'm going to pause the video. We're going to list a few, and you'll be able to pause the video if you need. All right. All of these are examples of the sum of squares. So whether they're both positive or whether they're both negative, the pattern is this. Add them to each other, you get the middle one. Multiply them to each other, you get the last constant at the end. Okay? So we've got a negative 4, we've got a negative 4, they add together to equal a negative 8, they multiply together to equal a positive 16. Over here, what's the difference between a sum of squares and a difference of squares? Here we're always going to have what? A minus and a plus. Here we always have the exact same sign. If you go over to our problem, what is x squared minus 4x plus 4 factor to? X minus 2 and x minus 2. Because a negative times a negative is a positive, but a negative 2 plus a negative 2 is a negative 4. So what was one of our factors? One of our factors is actually an x plus 3. What are our other two factors? An x minus 2 and an x minus 2. So what I want you guys to do right now, if I asked you for the factored form that we just did, previous assignment, this would be the what? The factored form of what problem? That's the factored form of problem number 1. So what I'd like you to do, integrate the calculator right now. Integrate the calculator. Hit y equals. We're going to type in problem number 1. Problem number 1 says x to the power of 3. Then it says minus an x squared. Then it says minus an 8x. So please type this in with me. And then it says plus a 12. Okay, so type it in with me, please. So type that in exactly as it appears right there. Just type it in. Now, underneath it, what I want you to do is I want you to open parentheses, do x plus 3, close parentheses, do x minus 2, and another x minus 2. We said this was the what? The factored form. Once you type those in, hit graph. Did you guys notice how it traced it? Okay? Look very carefully at these zeros. That's a 0, and that's a 0. What are our actual zeros? Our actual zeros are at a negative 3 and a 2. There's a concept right here. Whenever you know it's x cubed, how many zeros could we have? If it's x cubed, we could have 3. How many do we end up with? 2. You see how the graph touches it. It doesn't do what? It doesn't pass through it where you have 2. It touches it. That lets you know any time it just touches the graph right here, you have this concept called multiplicity. If I see a graph that touches that right there on the x-axis, I know I actually have 2 zeros just at the exact same point. Let me prove this to you, right? Check this out. Go to y equals, clear this one out, go down to this one right here, just change this to a plus 4. Change that to a 4. Go over here, change this to a plus 3, and another x plus 3. What's this 0 going to be at? Right there, this one. -4. How many zeros should we have right here? Technically, we only have 1 0, right? But we should see it not cross, so it should just touch it. So they grab it. All right? They're like, yeah, it does. But if I zoom in, how many places does that cross? Just one time. See how it goes up and then it just touches it? What if I change this and go, I'm going to clear this out, and I do, let's do a parabola. X minus 2 times x minus 2. How many places does this touch the graph? Just one. But how many, I mean, I have 1 0, just happens to be the same 0 twice. Okay? So just remember that. If you have multiple zeros, it's just going to touch it and bounce off of it at that point. So some of you are probably, all right, what's the final answer? Just tell me the answer. I'm a teenager. Just tell me the answer. The answer to problem number 1 is this. Plus or minus a 1, a 2, a 3, a 4, a 6, and a 12. All right? Those are all the possible rational zeros. What are our actual zeros? We only had 2 actual zeros. One was at a -3, the other one was at a +2. So I need you guys to understand the difference between the word possible solutions and the actual zeros. Okay? So this is your final answer for problem number 1. All right? Thank you. Hope you had a wonderful rest and had a good nap during